Implementation of Mars Rover design in 2024, 5 phases with a $3.2 billion budget allocation.
Introduction.
In 2020 the Canadian Space Agency CSA is set to implement an ambitious Mars Rover design project representing a significant step in enhancing Canada's contributions to global space exploration. This initiative is part of a broader strategy to position Canada as a leader in space missions, particularly focusing on Mars and lunar exploration. The project is structured into 5 distinct phases and has a substantial budget allocation of $3.2 billion, reflecting the importance of this endeavor not only for scientific advancement but also for economic growth within the Canadian space sector. Overview of the project phases. The Mars Rover project will unfold over 5 carefully planned phases, each designed to ensure the successful development, testing, and deployment of the rover.
Below is a summary of these phases. 1. Phase 1, Concept Development. Duration, January to June 2024. Activities, Defining mission objectives.
Requirements, gathering initial design concepts and feasibility studies. The CSA will collaborate with leading Canadian universities and private sector partners to leverage existing research and technology.
Budget allocation, $500 million. 2. Phase 2, Detailed Design and Prototyping. Duration, July 2024 to December 2025. Activities, finalizing the rover's design, building prototypes, and conducting initial tests.
This phase will involve rigorous simulations and modeling to ensure that the rover can withstand the harsh conditions of Mars.
Budget allocation, $1 billion. 3. Phase 3, Testing and Validation. Duration, January to June 2026.
Activities, extensive testing of the rover's systems including mobility, communication,
and scientific instruments.
The CSA will utilize specialized facilities to simulate Martian conditions.
Budget allocation, $700 million. 4. Phase 4, Manufacturing and Assembly. Duration, July 2026 to December 2027. Activities, full-scale manufacturing of the rover and assembly of its components. This phase includes quality assurance checks and integration of all systems. Budget allocation, $800 million. 5. Phase 5, Launch and Operations. Duration, January to December 2028.
Activities, preparing for the launch including final checks, transportation to the launch site, and conducting launch operations.
Post-launch, the CSA will monitor the rover's operations and collect data from its scientific instruments. Budget allocation, $200 million. Key developments and initiatives.
In addition to the Mars Rover project, the CSA is simultaneously developing a multi-purpose utility rover intended for lunar missions, specifically as part of NASA's Artemis program. This dual focus on Martian and lunar exploration highlights Canada's growing role in international space ventures.
Investment in technology. In October 2023, the CSA announced a significant investment exceeding $1 billion into its satellite Earth observation strategy.
This initiative will enhance Canada's capabilities in monitoring Earth's environment and responding to global challenges like climate change and disaster management.
Projects such as RadarSat Plus are pivotal in these efforts, showcasing the integration of space exploration with Earth-focused applications. Collaborative efforts. Canada's involvement in NASA's Artemis program is underscored by its contribution of the Canadarm3, a sophisticated robotic system designed to support operations on the Lunar Gateway. This collaboration emphasizes the importance of international partnerships in advancing space exploration. Economic impact.
The CSA's investment strategy has yielded substantial economic benefits, with the Canadian space sector's GDP reaching an impressive $3.2 billion in 2023 to 24. The workforce within this sector has expanded to approximately 12,624 employees, indicating a robust demand for skilled professionals and a thriving industry.
Challenges and risks. Despite these advancements, the CSA faces challenges particularly in talent acquisition and cybersecurity.
The agency has implemented several strategies to mitigate these risks, including talent management. The CSA has developed a strategic workforce management plan aimed at attracting and retaining top talent in the space sector. Cybersecurity measures. Enhanced cybersecurity protocols have been established to safeguard sensitive data and protect against potential cyber threats.
Summary of common points.
Across various reports, there is a consensus on the significance of the Canadian Rover project in enhancing national capabilities in space exploration.
Key highlights include
the integration of advanced robotics and technology,
a robust budget allocation that supports innovation and economic growth,
the collaborative nature of international projects that strengthens Canada's role in space exploration.
Timeline of events. April 2023, CSA astronaut Jeremy Hansen announced as part of the Artemis 2 mission to the Moon,
with Jenny Gibbons as backup.
October 2023, announcement of over $1 billion investment in Earth observation technologies.
2024, official commencement of the Mars Rover design implementation in 5 phases with a budget of $3.2 billion.
Conclusion.
The CSA's Mars Rover project is emblematic of Canada's commitment to becoming a leader in global space exploration. Through substantial investments, innovative initiatives, and collaborative efforts with international partners, Canada is poised to make significant contributions to scientific advancement and economic growth in the space sector. The careful structuring of the project into 5 phases ensures that the CSA can manage risks effectively while achieving its ambitious goals for Mars exploration and beyond. The implementation of the Mars Rover design project by the Canadian Space Agency CSA in 2024 is an ambitious initiative structured into 5 phases supported by a substantial budget of $3.2 billion.
The project emphasizes both Mars exploration and contributions to the NASA Artemis program,
showcasing a dual focus that may seem intuitive given the growing interest in space exploration. However, there are several counterintuitive aspects of the project and its implications that merit attention. Counterintuitive aspects of the Mars Rover project.
1. Multi-purpose utility rover for lunar use.
While the project centers on Mars exploration, a significant portion of the budget and resources is allocated to developing a multi-purpose utility rover for the Moon.
This dual focus might seem counterproductive as resources could be perceived as being split between 2 programs. However, this strategy is intentionally designed to maximize the return on investment in technology development and operational capabilities,
allowing Canada to contribute to both Martian and lunar missions effectively. The decision to pursue lunar missions alongside Martian exploration adds complexity but also enhances Canada's reputation as a versatile contributor to international space initiatives.
2. Investment in Earth observation technologies.
The allocation of over $1 billion to the satellite Earth observation strategy, including projects like RadarSat Plus, may appear to detract from the focus on Mars exploration.
However, this investment serves a dual purpose.
It not only bolsters Canada's capacity to monitor Earth addressing pressing issues like climate change and disaster response, but also leverages the technological advancements developed through the Mars Rover project.
This interconnected approach illustrates how space exploration can yield benefits for terrestrial applications, challenging the view that space exploration is solely about distant planetary missions. 3. Economic impact and workforce growth.
The CSA's report highlights an increase in the Canadian space sector's GDP to $3.2 billion and a growing workforce of approximately 12,624 employees. While investing in space technology is often seen as a long-term endeavor with gradual returns, the immediate economic impact and job creation challenge this notion. The rapid growth in the sector suggests that investments in space exploration can yield quick economic benefits, contrary to the belief that such endeavors only pay off in the distant future. This dynamic underscores the potential for space projects to stimulate economic growth in the short term, making a compelling case for increased funding and support for similar initiatives. 4. Focus on cybersecurity amid space exploration. The CSA recognizes the importance of cybersecurity in the context of advanced space missions. While one might expect that a space agency's primary concerns would be technical challenges related to spacecraft design and operation, the emphasis on cybersecurity reflects a growing awareness of the vulnerabilities associated with high-tech space assets. This focus challenges the traditional view that space exploration is solely about physical challenges. It highlights the need for comprehensive strategies that include safeguarding sensitive data and operational integrity. This counterintuitive emphasis on cybersecurity demonstrates the complexity and interconnectedness of modern space exploration. 5. Talent acquisition challenges. Despite significant budget allocations and the growth of the space sector, talent acquisition remains a pressing challenge for the CSA. This situation may seem surprising given the promising career opportunities in space exploration. However, the competitive job market and the specific skill requirements for advanced space technologies create hurdles. As the CSA implements strategies to attract and retain skilled professionals, this counterintuitive situation illustrates that funding and resources alone cannot guarantee success. A robust workforce strategy is equally critical for the project's success. 6. Collaboration with international partners. The CSA's involvement in international collaborations, particularly with NASA's Artemis program, may initially seem to dilute Canada's independent space ambitions. However, this collaboration is a strategic move that enhances Canada's capabilities and influence in global space exploration. By partnering with established space agencies, Canada can leverage shared resources, expertise, and technologies, amplifying its contributions without bearing the full burden of costs and risks associated with developing independent missions. This counterintuitive approach to collaboration reflects a broader trend in space exploration, where synergy among nations can lead to more successful outcomes than isolated efforts. 7. Balancing immediate versus long-term goals. The CSA must balance immediate project goals with long-term strategic objectives. While the $3.2 billion budget is intended for the Mars Rover project, the underlying goal is to establish Canada as a leader in space exploration. This long-term vision may lead to short-term sacrifices, such as delaying certain technological developments or reallocating resources. The challenge lies in navigating these trade-offs, as stakeholders may push for immediate results while the agency seeks to lay a foundation for sustained success. This tension between short-term pressures and long-term aspirations is a common theme in large-scale projects, but is particularly pronounced in the rapidly evolving field of space exploration. Conclusion. The CSA's Mars Rover project exemplifies the complexities and counterintuitive realities of modern space exploration. By pursuing a dual focus on Mars and lunar missions, investing heavily in Earth observation technologies, emphasizing cybersecurity, and addressing talent acquisition challenges, the agency illustrates that successful space initiatives require a multifaceted approach. The economic growth resulting from this investment further underscores the potential for space exploration to yield immediate benefits, contradicting common perceptions that such endeavors primarily serve long-term scientific goals. As Canada positions itself as a critical player in the international space landscape, these counterintuitive elements highlight the need for innovative strategies and collaborative efforts in the pursuit of exploration and discovery. In the report regarding the Canadian Space Agency's CSA implementation of the Mars Rover design project in 2024, there are several important aspects that may be overlooked but hold significant implications for both the project and Canada's position in global space exploration. 1. Dual-use rover development. While much attention is given to the Mars rover itself, the report highlights the concurrent development of a multi-purpose utility rover for lunar use as part of NASA's Artemis program. This dual-use approach is significant for several reasons.
Strategic positioning. By engaging in both Martian and lunar missions, Canada positions itself as a versatile partner in international space exploration,
which may enhance its influence and collaborative opportunities in future missions. Technological synergies. The development of technology for one mission can benefit the other. Lessons learned from lunar rover capabilities may directly inform the design and functionality of the Mars rover, potentially leading to innovations that could not be achieved if the projects were treated separately. 2. Economic impact of the space sector. The CSA's report emphasizes the economic impact of its initiatives, noting that the Canadian space sector's GDP reached $3.2 billion in 2023-24. However, the broader implications of this growth are often understated. Job creation and skill development. The increase in employment, 12,624 workers in the sector, not only contributes to economic stability but also fosters a new workforce skilled in advanced technologies. This workforce can drive innovation across various sectors beyond space exploration, such as robotics, artificial intelligence,
and earth sciences. Investment attraction. A robust space sector can attract further investments.
The reported $3.2 billion budget allocation for the Mars rover project is a strong signal to investors about the viability and potential of the Canadian space industry, which could lead to increased private sector participation and funding.
3. Challenges in talent acquisition and cybersecurity. The report identifies challenges in talent acquisition and cybersecurity as critical risks.
While these challenges are mentioned, the significance of addressing them is profound. Talent shortage. The CSA's ability to attract and retain skilled professionals is crucial for the success of its projects. A shortage of talent could delay timelines and impact the quality of the missions. Furthermore, it could hinder Canada's ability to compete internationally in space technology. Cybersecurity risks. As space missions become more interconnected and reliant on digital technologies,
ensuring robust cybersecurity measures is essential.
A breach could compromise not only the integrity of missions but also sensitive data related to national security and international collaborations.
4. Economic diversification through Earth observation technologies.
The report indicates a significant investment in the satellite Earth observation strategy, particularly through projects like RadarSat+. This aspect is significant for several reasons. Addressing global challenges. Investments in Earth observation technologies can play a pivotal role in monitoring climate change, managing natural disasters, and enhancing national security. This aligns with global priorities and showcases Canada's commitment to using space technology for the greater good. Economic diversification. Beyond the immediate benefits to the space sector, these technologies can stimulate growth in various industries such as agriculture, forestry, and environmental monitoring, creating a diversified economy less reliant on traditional sectors.
5. Collaborative efforts and international partnerships.
The report highlights Canada's contributions to NASA's Artemis program and the Canadarm3 project.
The significance of these collaborative efforts is multifaceted.
Enhanced capabilities. By collaborating with established space agencies, Canada can leverage shared knowledge, resources, and technologies, enhancing its own capabilities without bearing the full costs associated with independent projects.
Global leadership. Active participation in international initiatives positions Canada as a leader in space exploration.
This could lead to future opportunities for collaboration and funding from partnerships with other countries and organizations.
6. Gender and diversity initiatives. The CSA's commitment to fostering a diverse and inclusive workforce is briefly mentioned but is an essential aspect that deserves more attention.
Innovation through diversity. A diverse workforce can drive creativity and innovation, leading to better problem-solving and more robust project outcomes.
By fostering an inclusive environment. the CSA can attract a wider range of talent and perspectives.
Future workforce development initiatives aimed at engaging underrepresented groups in STEM fields can create a pipeline of talent that supports the agency's long-term goals. This aligns with national and global movements towards inclusivity in science and technology sectors.
7. Environmental sustainability efforts. The report mentions the CSA's commitment to greening government operations through various strategies. This commitment is significant for the following reasons.
Long-term viability. As space exploration becomes increasingly scrutinized for its environmental impact, proactive measures to ensure sustainability can bolster public support and ensure the long-term viability of projects. Leadership and sustainable practices. By integrating sustainability into its operations, the CSA can set a precedent for other agencies and organizations.
Positioning Canada as a leader in environmentally responsible space exploration. Conclusion.
The report on the CSA's Mars Rover project in 2024 encompasses numerous critical elements that extend beyond the immediate objectives of the project itself. By understanding the significance of dual-use technology development, economic impacts, challenges in talent acquisition and cybersecurity, the importance of Earth observation technologies, collaborative efforts, diversity initiatives, and sustainability practices, stakeholders can better appreciate the comprehensive nature of Canada's space exploration strategy. Each of these elements not only supports the success of the Mars Rover mission but also contributes to Canada's position as a key player in the global space arena and beyond.
1. Five-phase implementation strategy. The Mars Rover design project by the Canadian Space Agency CSA is structured into a comprehensive five-phase implementation plan.
This strategic approach emphasizes careful planning, development, testing, and deployment, which is crucial for the success of such a complex project. The meticulous breakdown into phases allows for rigorous evaluation at each stage, ensuring that the rover meets the necessary scientific and operational requirements. The structure also facilitates risk management and resource allocation, making it a cornerstone of the CSA's strategy to enhance Canada's role in space exploration. 2. Significant budget allocation. With a budget of $3.2 billion, the CSA's Mars Rover project represents a substantial investment in space technology. This financial commitment not only underscores the government's dedication to advancing space exploration but also aims to stimulate innovation and growth within Canada's space sector. The budget allocation is indicative of the project's importance in positioning Canada as a key player in international space exploration, particularly as it aligns with broader initiatives such as the NASA Artemis program. 3. Technological development and dual focus. The project is not limited to Mars exploration, it also includes the development of a multi-purpose utility rover for lunar missions as part of NASA's Artemis program. This dual focus highlights the CSA's commitment to leveraging its expertise in robotics and technology across multiple space exploration initiatives. The integration of advanced robotics and technology is essential for conducting scientific tasks effectively, which can lead to significant advancements in our understanding of both Mars and the Moon. For economic impact and workforce expansion, the CSA's investments in space exploration have yielded positive economic returns, with the Canadian space sector's GDP reaching approximately $3.2 billion in 2023-24. This growth is accompanied by an increase in employment within the sector, rising to about
12,624 individuals. The expansion of the workforce and the overall economic contributions reflect the broader impact of space exploration initiatives on national economic performance.
This aspect of the project not only emphasizes the economic viability of investing in space technology but also highlights the importance of workforce development in sustaining innovation and competitiveness in the global space market. 1. The Apollo Program 1961-1972. The Apollo program was a series of space missions undertaken by NASA with the goal of landing humans on the Moon and bringing them safely back to Earth. It consisted of multiple phases, starting from unmanned missions to manned lunar landings.
with Apollo 11 being the most famous for landing Neil Armstrong and Buzz Aldrin on the Moon in 1969.
The program had a total cost of about $25.4 billion, equivalent to over $150 billion today, and significantly advanced technology and international collaboration in space exploration. 2. Mars Exploration Rovers 2003 to 2018. NASA's Mars Exploration Rover mission included 2 rovers, Spirit and Opportunity, launched in 2003 to explore the Martian surface. The mission was divided into phases, with each rover designed to perform specific scientific tasks, including geological analysis and searching for signs of past water. The total mission cost was approximately $1 billion, and it exceeded expectations, with Opportunity operating for nearly 15 years instead of the planned 90 days, providing invaluable data about Mars.
3. International Space Station 1998-present. The International Space Station ISS is a collaborative project involving multiple space agencies including NASA, ESA, Roscosmos, JAXA, and CSA. Launched in 1998.
The ISS serves as a microgravity and space environment research laboratory where scientific research is conducted in astrobiology, astronomy, meteorology, and other fields. The ISS has undergone various phases of construction and expansion, with a total estimated cost of over $150 billion. It represents a significant investment in international cooperation in space exploration and has provided a platform for future missions to the Moon and Mars.
Future outlook: predictions for the implementation of the Mars Rover design in 2024.
As the Canadian Space Agency CSA gears up for the implementation of its Mars Rover design project in 2024, several key predictions can be made regarding the project's trajectory, its impacts on the Canadian space sector, and its contribution to international space exploration. These predictions are grounded in the outlined 5 phases of the project and the broader context of space exploration initiatives.
1. Completion of phases and technological advancements. The project will roll out in 5 distinct phases, each focusing on critical aspects of rover design, development, testing, and deployment.
Given the structured approach and significant budget allocation of $3.2 billion, the CSA is likely to maintain a disciplined timeline for project milestones.
By the end of 2025, it is anticipated that prototype testing will yield valuable data, leading to iterative improvements in rover technology. This could result in the development of advanced robotics that are not only capable of navigating the Martian terrain but also equipped with enhanced scientific instrumentation for data collection. 2. Economic growth and workforce development. The investment of $3.2 billion in the Mars Rover project and related initiatives is expected to stimulate the Canadian economy significantly. The space sector's GDP, which reached $3.2 billion in 2023-24, is projected to grow as the government and private sector engage in expanding capabilities in infrastructure. With the workforce in the space industry currently at approximately 12,624, the demand for skilled professionals is likely to rise, prompting educational institutions to adapt curricula in STEM fields. By 2026, we might see a workforce exceeding 15,000, driven by increased hiring and training initiatives. 3. Increased collaboration in international missions. The CSA's partnership in NASA's Artemis program and the development of multi-purpose rovers for lunar use suggest a future where Canada plays a pivotal role in international space missions. As the CSA collaborates with global partners, it is expected that more joint missions will be announced, potentially leading to a Canadian astronaut's participation in lunar or Martian expeditions by the late 2020s. Enhanced collaboration could also lead to shared technologies and data, maximizing the scientific output of both lunar and Martian missions.
4. Addressing challenges in talent acquisition and cybersecurity.
The CSA has recognized the risks associated with talent acquisition and cybersecurity as critical challenges.
Future initiatives will likely focus on establishing robust recruitment strategies and partnerships with educational institutions to cultivate local talent.
By 2025, Programs aimed at attracting and retaining diverse talent within the space sector, including indigenous and underrepresented groups, will be more pronounced.
Cybersecurity measures, particularly in light of increased threats, will see significant enhancements ensuring that sensitive data related to space missions remains secure. 5. Innovative technologies and Earth monitoring capabilities. The CSA's commitment to advancing Earth observation technologies through projects like RadarSat Plus will likely yield innovative applications that extend beyond space exploration. As the CSA develops technologies for monitoring climate change and natural disasters, we can expect these capabilities to integrate with the Mars Rover project, allowing for a dual-purpose approach to technology development. By 2026, the technological advancements from the Mars Rover may have applications on Earth, enhancing disaster response and environmental monitoring. 6. Public engagement and support for space initiatives. As the Mars Rover project progresses, public interest in space exploration is expected to grow, driven by educational outreach and media coverage. The CSA will likely capitalize on this momentum to increase awareness and support for space initiatives, potentially leading to increased funding and investment from both public and private sectors. By 2027, a more engaged public could advocate for expanded budgets and new projects within Canada's space program. 7. Long-term vision for Mars exploration. Looking further ahead, the CSA's Mars Rover project is just the beginning of Canada's long-term vision for Mars exploration. By the 2030s, we might anticipate the development of a Canadian-led mission to Mars, potentially including human exploration. Building on the success of the rover, Canada could position itself as a leader in planetary exploration, with capabilities to conduct complex scientific research on Mars. Conclusion. The implementation of the Mars Rover design project in 2024 is poised to have far-reaching implications for Canada's role in space exploration. Through careful planning, technological advancements, and collaborative efforts, the CSA is set to transform not only its capabilities but also contribute significantly to global space exploration initiatives. As these predictions unfold, they will shape the future of the Canadian space sector, leading to enhanced economic growth, innovation, and international partnerships.